video lecture is meant to cover the information from Chapter 11, which is Unit 10, Objective number 4, which says to balance chemical equations using the smallest whole number ratios and understand the reason why equations have to be balanced. If we were to look at an equation like this one, hydrogen gas plus oxygen gas, when ignited together, will produce water. Now, for right now, I'm not going to include states of matter or energy. What I want us to focus on right now is that, number one, the chemical formulas have been written correctly. But when we look at this chemical equation, what you might notice is that the number of atoms on the left side do not equal the number of atoms on the right side. And that brings us to this reason why equations have to be balanced. The reason why equations have to be balanced is better known as the law of conservation of mass, or of matter, which says that matter cannot be created or destroyed. So we have to account for however many atoms we have on the left side of the arrow in the reactant side of the equation, have to also show up on the right side of the arrow or on the product side of the equation. So one way, and this is a fairly simple equation, but I'm going to show you a technique that you can use, and I'm going to encourage you to use this technique, especially on the equations that are really stubborn to balance. Now the first thing I'm going to do is I'm going to put a line in front of each one of these chemical formulas because the line is a blank space. And in this blank space we are going to put what are called coefficients. Right? These coefficients are going to be a whole number ratio, so we can't have fractions in those blank spaces. So to do an inventory, and again this is going to seem rather simple because this is a pretty simple equation, I'm going to have you write out what is called an ERP table. ERP. E standing for elements, R standing for reactants, and P standing for products. If you look at this equation, there are only two elements involved. Right? So the elements hydrogen and oxygen, you would write them down in the E column to say that those are the elements found in this equation. Under the R and the P columns, we're going to take our inventory. So on the reactant side is anything to the left of the arrow. How many hydrogens are on the reactant side? Well, according to the subscript right here, we see that there are 2 hydrogens. On the reactant side, we see that there are 2 oxygens. Now, let's take a look at the product side. Everything to the right of the arrow, there's only one product here. But we see that there are 2 hydrogens present, but only 1 oxygen. So your goal is to make these numbers balance between the reactants and the product column, and we see that they are not. So right now, if we left this equation as is, it violates the law of conservation of matter. So to do that, we can clearly see that we need more oxygens on the product side. So what we want to do is we want to make sure that there are 2 oxygens. So you start by putting a 2 in front of the compound containing the oxygen. But of course that's going to cause your numbers in the product column to change. So let's adjust those. That does give us our 2 oxygens, but it also changes the number of hydrogens to be 4 hydrogens. So we've balanced the oxygens, but in the process we've thrown off the hydrogens. But this is a pretty easy fix, so let's go to the hydrogens on the reactant side. How can we make the hydrogens on the reactant side equal 4, so that it balances it over here with the product hydrogens? Well, if you were to put a 2 in front of the H2, that would give you a total of 4 hydrogens on the reactant side. So here we have 4 and 4 hydrogens and 2 and 2 oxygens, and so this equation is now balanced. Now, the coefficient in front of the oxygen is a 1, and you can write the 1 in, or you can leave this blank. A blank coefficient is an assumed 1. I'm going to put a 1 here just for emphasis to make sure that you understand that there's just one of those oxygen molecules present. So what we can see now here is that we have the 2, 1, 2. That is the smallest whole number ratio that we can make for this. That 2, 1, 2 is not reducible down to a smaller whole number ratio. So this equation is good to go. All right, let's take a look at the reactions that we worked with previously in class. And we can see here, if we were to create an ERP table, there are lead, Pb, there's nitrogen, there's oxygen, there's potassium, and there is iodine. So let's do our inventory. On the reactant side, there is 1 lead. There is 2 nitrogens. There are 6 oxygens, 1 potassium, and 1 iodine. On the product side, we have 1 potassium. We have 1 nitrogen. We have 3 oxygens. Oh, I did this wrong, didn't I? All right, let's go back. They're not in the same order. I guess we need to watch out for that. Even I got duped by it. Leads, there is 1 lead. Nitrogen, there is 1 nitrogen. Oxygen, there are 3 oxygens. Potassium, 1. Iodine, 2. So here we see that nitrogen, oxygen, and iodine are out of balance. So let's try to fix one of those elements. I'm going to start with nitrogen just because it's the first element down the list that is not balanced. So what I want to do is to make the nitrogens on the product side be equal to 2. To do that, I'm going to put a 2 in front of the KNO3. Now, we have to adjust our inventory. That makes us have 2 potassiums, 2 nitrogens, and 6 oxygens. Okay? So by putting the 2 in front of the KNO3, we've adjusted the nitrogens, we've adjusted the oxygens, but we've thrown off the potassiums. Okay? So now let's see what we can do about fixing the potassiums on the reactant side. Let's work on this number right here. Okay? We need to match that up to 2, the 2 potassiums that are now on the product side. So let's put a 2 in front of the Ki. And now we have to adjust our inventory. 2 potassiums, 2 iodines. And with that, we can see that we now have reactants equal to products. So our coefficients are 1, 2, 2, 1. Let's take a look at the second equation that we have here. Let's create an ERP table. The elements we have here are aluminum and chlorine. That's it. On the reactant side, I have 1 aluminum and 2 chlorines. On the product side, I have 1 aluminum, but I have 3 chlorines. So here's the thing, when you have this 2, 3, it seems a bit awkward at first, but you'll soon get familiar with these on what to do. Remember, you have to only multiply, you have to use whole numbers in the coefficients. So I see here that I need to have more, we need to work on the chlorines. And when you have this 2, 3 split like this, the easiest thing to do is to multiply each side by the other number. So for example, if I were to multiply this chlorine here by 3, and this chlorine over here by 2, that will be the, what is that called, the least common multiple, I think is what that's called. So let's start with this chlorine reactant on the left side to make this be equal to the chlorines on the right side. Let's start by putting a 3 in front of the Cl2. If I do that, that's going to give me 6. It's a messy 6. It's going to give me 6 chlorines on the reactant side. Right, but now we can see that this 3 chlorines on the product side, if I multiply that by 2, by putting a 2 in front of the AlCl3, I will get 6 chlorines, but at the same time it messes up my aluminums to now have 2 aluminums. Alright, so now we have to go and fix the aluminums on the reactant side, but this is an easy fix because aluminum's all by itself. So putting a 2 in front of the aluminum adjusts the number of aluminums from both the reactant and the product side. So the 2-3-2 ratio is the lowest whole number ratio, and so this reaction is balanced. All right, so this equation is going to be a little bit trickier, and you'll see why here in a moment. Our elements are hydrogen, oxygen, and sodium. On the reactant side, we have 2 hydrogens, 1 oxygen, 1 sodium, On the product side, I have 3 hydrogens because the hydrogen is split between these two compounds. That's what makes this a little bit more challenging to balance. I have 1 oxygen and 1 sodium. So we need to figure out how to make our number of hydrogens balance on both sides. Sometimes this is a bit of trial and error, but let's take a look. Since we have the hydrogen split between 2 compounds, we're going to try a different method other than the 3-2 split that we did in the last equation. It would be easier if we had an even number of hydrogens on the right-hand side, on the product side. Then we could adjust the coefficient in front of the water molecule because it's an already even number, so that's would be easier to fix. So focusing on the product side, how can we make the number of hydrogens be an even number? Well, we've got 2 in front of the hydrogen right here, but 1 here. So if we adjust this coefficient in front of the NaOH, let's make it a 2. Let's see what happens when we do this. If I do the 2 in front of the NaOH, I will get, on the product side, a total of 4 hydrogens, 2 oxygens, and 2 sodiums. So right now it seems kind of bleak, right? It seems like we just messed everything up. But here's where you have to have faith, okay? So use that faith to persevere here. If we wanted to adjust the hydrogens on the reactant side, now it's easy because there's 2 hydrogens here. If we put a 2 in front of the H2O, that's going to automatically adjust our hydrogens to be 4. Okay, so this is looking better. Our hydrogens are now balanced. But that also changes the number of oxygens to be 2. Hey, this is going pretty well, which seems to be working. The last element that's not balanced is sodium, but this is an easy fix because sodium on the reactant side is all by itself. So putting a 2 in front of the sodium automatically makes this equation balanced. So our coefficients are 2, 2, 2, and I'm going to put a 1 in there next to the hydrogen gas at the end. All right, let's take a look at equation number 4, setting up our ERP table. Our elements here are just nitrogen and iodine. On the reactant side, I have 1 nitrogen and 3 iodines. On the product side, I have 2 nitrogens and 2 iodines. So let's start with nitrogen. Let's try to adjust that nitrogen. I need more nitrogens on the reactant side, so I'm going to put a 2 in front of the Ni3, which will then adjust my nitrogens on the reactant side to have 2 nitrogens and 6 iodines. Okay, well, that works for the nitrogens, but now we have to adjust the iodine on the product side. Right? So if I were to put a 3 in front of the I2, that would give me 6 iodines on the product side, and everything is balanced. So our coefficients here are 2, 1, and 3. Last equation here. Our elements: carbon, hydrogen, oxygen. On the reactant side, I have 1 carbon, 4 hydrogens, 2 oxygens. On the product side, I have 1 carbon, 2 hydrogens, and 3 oxygens. So here's a situation where we have the 3-2 split, but the oxygens are across 2 different compounds. So the best strategy here is to make our odd number of oxygens on the product side. We need that to be a total of we need it to be an even number on the product side, and that'll make this process a bit easier. So let's work on that oxygen first to give us an even number of oxygens on the product side. To do that, let's start simply by putting a 2 in front of the H2O. So on the product side, we now have 4 hydrogens and 4 oxygens. Well, that's good. That fixed our hydrogens, but it did not fix our oxygens. But now you can see it's easier to fix the oxygens because all I need to do is put a 2 in front of the O2, and that will give me 4 oxygens. And there it is. That one was not too bad. Our coefficients are 1, 2, 2, 1. Now you can see here that the ERP table is sort of a way to kind of keep track of all the elements on both sides of the equation. I'm going to recommend it as a tool if you don't have a whole lot of confidence in balancing equations. I'm not going to require that you use it. So if you think you can balance the equations without using a table, go right ahead. The tool is just meant to be a very methodical device to help you keep track of what's on the left and what's on the right side of the equation. All right, this has been a video lecture on balancing equations. We'll see you in the classroom.